Everyone loves glitter, except for the fact that it gets everywhere, and it'll be stuck to you, your clothes, your floor, and all your possessions for weeks. Thankfully, if we stick the glitter inside a shader instead, we'll avoid the glitterpocalypse, and it's more environmentally friendly too. In this tutorial, we're going to use a special noise texture, a few math tricks, and some emissive light in order to make some glistening, glittery crystals. And if you stay until the end, I'll show you how to flip the whole thing on its head and turn it into a starry night skybox. I'll be using Unity 2020.3 and all of the code will be available on GitHub. Let's jump in. The approach we're going to take with this shader is to generate a random direction at every point on the surface of the object. Depending on the angle between that direction and the vector between the camera and the surface will shine. If we generated the correct pattern to begin with, then the object will look glittery. We'll then stick some Fresnel around the edges and add a soft colour gradient, and that's our glitter shader done. We'll start off, as usual, by right-clicking and selecting Create, Shader, Universal Render Pipeline, Lit Shader Graph. I'm also going to generate a noise cloud texture to use for those random directions. You can do this in many image programs and the process should be similar, but I'm going to open GIMP, make a new 256x256 texture, and go to Filters, Noise, Hurl, set repeat to about 50, and click OK. Export that somewhere in your Unity project. You can use other types of noise, but the point is to use something that generates colours like these. We'll add some properties to get us started with the noise. The first is noise texture, and this will be the texture we just generated. Then we will have noise scale, which is a vector 2 which lets us tile the noise texture across the mesh. Use a sample texture 2D node to sample the noise texture. In the UV slot, we're going to plug in a tiling and offset node. The noise scale goes in the tiling pin. That will let us adjust the material so that the glitter particles get bigger or smaller. Each of the colours currently applied to the object are going to be used as directions. Colours are made up of red, green and blue components, which we can very easily treat as the X, Y and Z components of a direction vector instead. That's exactly what we're going to do. There's two modifications to make to these directions. Firstly, I want to add the ability to shift directions over time, and secondly, I want to set up a threshold for the glitter to make sure that we don't have too many reflective particles. For that, add two float properties called noise rotation speed and glitter offset respectively. To shift the colour over time, we'll use a hue node. This will cycle the colour through red, to orange, to yellow, to green and so on, while preserving the amount of saturation and lightness in the colour. And the result for us is a direction vector which rotates over time. Multiply noise rotation speed by time and plug it into the offset pin. Then, to threshold the glitter and remove some of the reflections, subtract glitter offset from the output of the hue node. This will make some of the direction vectors point inwards towards the centre of the object, and therefore will end up hidden later. Normalize the result to make the direction vector's length 1. Remember that we're going to take the angle between these random directions and a vector between the camera and the surface of the object. Now it's time to calculate that second vector. Unity provides the view direction node, which we'll use in world space. Normalize that too, and then take 1 minus the result, because it's pointing in the opposite direction to what we need. With these two vectors, we can now figure out the angle. Well, not exactly. We just want a number that gets higher when these vectors point in the same direction, and lower when they point away from each other. For that, we can use the dot product. Saturate the result so that values below 0 are clamped to 0. Now we're going to add colour, and make everything glow spectacularly. Let's add another property called glitter colour. This time, we'll make it an HDR colour by changing the mode. Since the output from the dot product is just a grayscale value, and outputs white where we want the glitter chunks to appear, we can multiply by glitter colour to get the final glitter colour. But of course, we're not quite done with the shader. I want to add a slight glow to the edges of the object. Fresnel light is perfect for this, so we can use Shader Graph's Fresnel Effects node. For the power pin, we will plug in a new property called Fresnel Power to control how strong the glow around the edges is. Since the Fresnel values generated by the node are between 0 and 1, Increasing the power pulls the white towards the edges. Then we will create a second color property called Fresnel Color, which also needs to be HDR enabled, and multiply it with the Fresnel. We will add this and the glitter result together, and then output the combined result to the emission pin on the output stack. Even now, if you use this shader on a material and set appropriate values, you'll be able to make a great glitter effect. But the base colour is very bleak, and I think we need to add a bit more colour. I'm going to create a simple colour gradient along the object running from the top to the bottom. For that, I'll use a UV node, then split its components and pick the G component. This corresponds to the vertical component of the UVs. Here's where your graph might differ. I chose to do it this way because the objects I'm using have their UV's vertical component mapped 0 to 1 from bottom to top. You could use a position node in object space, but take note of the fact they can run into negative values if the object's pivot point is somewhere in the middle. Now we will need 3 new properties. The gradient will be made up of 2 colours, so I'll just call them base colour 1 and base colour 2. Inventive, I know. Followed by a float property called base gradient power. This one will control how quickly the gradient transitions between the 2 colours. We want to interpolate between the 2 base colours, so take the UV's vertical component and raise it to the power of base gradient power. Then use the result in a lerp node's T slot, which represents the interpolation factor, or in simpler terms, how far we are between the 2 colours. The 2 colours go into the A and B slots, and the result is output to the base colour pin on the output stack. You might want to handle the transition between both colours differently, so feel free to make it completely linear instead of using the power if you want. And if you want to use transparency at all, you can set the shader to use transparent rendering in the graph settings, then split the result and use the A component in the alpha pin on the output stack. Go ahead and tweak the material values and assign whatever noise texture works best for you, and you should see a glistening, glowing glitter effect. You could use this whenever you want something to take on an enchanted or magical appearance, or maybe use it to emulate tiny chunks of metal inside a rock. And you've got to admit, it's far better than opening a glittery birthday or Christmas card and coating the damn stuff over everything in a 2-mile radius. Before we look at this video's extra twists, I'd like to thank all my Patreon supporters for making this video and all my others possible. If you learned something today, make sure you subscribe and hit the bell icon to get notified whenever new tutorials drop. Also, because I'm excited and I wanted to fit this in somewhere, I'm writing a book about shaders. Like, a real physical actual book. It's gonna take a while to make, so keep an eye out for more news in the near future. For today's super special extra classes, we're going to turn our gorgeous glitter into a sparkling night sky. I've duplicated the shader, then we'll head over to the graph settings and change the shader to unlit, opaque, and 2-sided. That seems like a big change, but we don't actually need to change much on the graph itself. Remove all nodes and properties to do with Fresnel and alpha, and then instead of using emission, just add the glitter colour and the base colour together and output to base colour on the output stack. Back in the scene view, add a huge sphere, then add a glitter material using dark base colours to it. If you tweak around the values a little, you can make a starry night similar to this one. I'll be back soon with more videos, including a detailed rundown of the maths knowledge required for making shaders, which is increasingly becoming one of the most requested topics for me to cover. Until next time, have fun making shaders.